Alrighty. Hey everyone, thanks for watching. Today I'm going to be going over my latest project using NFL data. Um, the project is based on explosive plays. I created a binary classification model that predicts the likelihood of a play being explosive. I define explosive by being a play that gained 13 yards or more in the air or 10 yards or more on the ground. So the ultimate goal was to not only model the event's accuracy, but to present them in a clear and professional visualized storytelling kind of way. So the first few steps are going to be data wrangling and engineering. So I'm going to read through them, and then we'll get to the latter half of the code where we start to play more with the modeling, the visualizations, the tables, and the results. Again, all just trying to predict if a play is going to be explosive or not. So we have our libraries, and we're using the data from 2016 to 2022, the play-by-play data. And this just happens to be, once we're done, these are the two files that you would need to just run my whole code, which I have on GitHub as well. So if you could follow along through there as well. Then we get started. So I'm going to read through the first few steps, and we'll go from there. So to begin, we did data wrangling across several data sources. So first I acquired the play-by-play data, and then I isolated the relevant pass attempts and the rush attempts, which were the ones that were marked as explosive, which were because they were either 13 yards passing or 10 yards rushing. So then after aligning those, I joined the schedule level metadata. So that's right here where we start joining the NGS and the metadata. So I start joining that, which included schedule, game ID, weather, temperature, team matchup information. Then I also added the participation data to capture which players were on the field during each play. And of course, I added some next-gen stats to bring time-based data into the analysis. So features like average time to line of scrimmage and number of defenders in the box. So those are our first three steps or so. Then we moved on to some feature engineering stuff. So I designed a number of contextual features to capture game situations, such as whether they play occur before the 2-minute warning, so like a 2-minute drive, whether the drive entered the red zone, whether it occurred late in the half. So we engineer some steps there, and then as you can see, so then I develop a pre-processing pipeline using the Tidy Models ecosystem. This included normalization of all continuous variable, one hot encoding for categorical variables like play type and personnel grouping, and unsampling of the minority class to address the imbalance between explosive and non-explosive plays. So some of those right here. So then after processing, the data was split into training and testing sets. So after this, we get to here, and we get into this part. So this is one of the last few steps before we get into real modeling and the visualizations, which I really want to get to, so we can focus on some of the results, which I think are a little more fun to talk about. I set my city to 90210. I don't know why. So then we are at the processing. So then after the processing, we're going to do the data, split it into training and testing sets with stratification to preserve class distribution. And then from there, I implemented a 10-fold cross validation strategy and began tuning the XGBoost classifier, right? So in this step is when we do the one hot encoding that I was talking about. Boom, boom, boom. Then here's when we start getting to the fun stuff. So this step took my computer 3 hours to do. So when I was first doing it, I was doing a 5-fold, and my grid is actually a 20 grid, not a 10 grid. That's from the training. So I did 5 and then 10 and then 20 on the grid. And then even the M-try range, I started with like 515 or something, and then I ended at 1050. I think the model said around 40 was the optimized level. But yeah, this one we ran a couple times to see the results and improve it slowly. Here is where we use 20 on the final run. It used to be 5. And this one also was 5, and so this was also 515. And to talk a little bit about this step, so the tuning was performed using the Latin hypercube sampling with 20 different parameter combinations, as I told you guys. I evaluated across a grid. So then we also I talked about the M-tries. So once I finished, I visualized the tuning results by plotting the ROC, AUC across each hyperparameter dimension. And then the plot revealed strong model responsiveness to increase the M-try and tree depth, indicating that complexity and breadth of features both help the model capture signal more effectively. So this is the first visualization that we get. That is, and I think it's probably one of the most important ones in the whole project. And I'll actually show you guys through the GitHub. And it's this one right here. So the way to read this is that, let's see. So the ROC increases as the number of randomly selected predictors increases. So right here in the first model here, right, the randomly selected one. So this suggests that your model benefits from evaluating a broader set of features at each split. So if you go to the learning rate one, these are on a log scale. So you can see performance improves as the learning rate increases. Extremely small learning rates underperform because the model learns too slowly, right? So the last one, the tree depth one, performance increases with tree depth up to about 6 or 8, then it levels off, right? Because you can see here, and then it levels off, right? So, and I wrote for all of them, but I'm just going over some of the more interesting ones. So ultimately, like, this tuning plot is a snapshot of how different XGBoost hyperparameter influence my model ability to separate explosive plays from non-explosive plays. The goal was to find the Goldilocks zone for each parameter, not too high, not too low, and maximize our ROC AUC. So it was like a roadmap. And so that's our first visualization that we start to plot from step 8 on forward. Then we move to step 9, which is our threshold. This also was a really important step um, about finding the threshold and optimizing the numbers. And so let me talk about this a little bit here. So we got this guy here. We have two visualizations here. I just personally really like this one. So this one has 3 lines, right? 3 metrics being tracked. Ultimately, threshold tuning is crucial. By default, we all start at 0.5, which is not always optimal. I've written in a few different numbers. I think I submitted the one that was 0.5. But the sweet spot depends on what's more important, right? So, for example, if we care more about catching all the explosive plays, even if some of them are false alarms, then we will lean towards the lower threshold, higher recall, right? And you see the blue line. But if you only want to flag plays you're confident are explosive, well, higher threshold, higher precision, right? If you want to balance, use the peak of the red line as your guiding threshold. So the F1, right? Yeah, the F1 score. Right? So that's why I thought this was a really fun visualization. Our range, by the way, well, let me show you the second one as well. So then we also have our confusion matrix, right? We left it at 0.5. I think our optimal range was between 0.25 and 0.30. FYI. And I also did not put a color gradient on this one. I feel like the white to gray made it work enough. Everything else is color gradient. So, I mean, this is, we all know about these. You have your true negatives, your false positives, your false negatives, and your true positives. So, with this one, we left it at 0.5, which means any play with a predictive probability over 0.5 was classified as explosive, and under 0.5 was non-explosive. Our true negatives are 21,980. Were classified as non-explosive, this is good. Our false positive, the top right, just in case I don't have it, show it to you. Plays were incorrectly flagged as explosive, but were not. This inflates the false alarms. 14,000 plays were explosive, but the model failed to predict them, so that is concerning. And then only about 5,000 plays were correctly flagged as explosive, 4,900, right? So, the model, I think, is good at predicting non-explosive plays. It's missing a lot of explosive ones, but we'll dive more deep into that. And this was our step 9. Then we have our step 10. I'm going to start moving along. Here I wanted to find the 20 most important features. So drive play count, what does that mean? That means that when a play was longer, there was the chances of having more plays where either a run was 10 yards or the pass was 13 yards. Which makes sense, because remember, I could have made the project so that 50 yards was an explosive play, but that would have been such a small sample size. This when you think of football, there are plays where you'll go 73 yards and 4 plays were over 13 yards maybe, right? And it's interesting to see that in longer drives, it happens more than in shorter drives, right? Shorter drives you get out, but it also means that if you have one play that is just a touchdown, so it's just interesting. That was the results of this one. Then we move into, and of course, other high impacted features include defensive yards per attempt and yards to go. Some of the features that I engineers like leverage score or long down distance also show up in the top 10, which is pretty cool. Then we run into the next step. I'm just going to show you the visualizations now. A top 20 player by XOE, so explosives over expected versus actual explosive plays. As you can see, Kirk Cousins has both a big circle, which means he had a lot of play, and he still was darker on the color scheme, which means that he's really impressive when it comes to this visualization to me. As you notice, a lot of quarterbacks, because they both run and throw the ball a lot, they have a lot of opportunities. That's why I have other images where I'm doing it by groups. So for example, I could show you the running backs, and then we see how someone like Blunt is all the way up here, even though he didn't get that many plays, and Bolden, right? Some people like Connor had a lot of plays, but not that high on the average XOE, right? So then we have, I did also a personnel average explosive over expected by personnel. So which personnel on defense led to more explosive plays. We move to our team level explosive. So this was cool because it's for the team. I'm assuming this is all Derrick Henry. That's what I'm thinking. Ryan Tannehill also had a good XOE, but I'm assuming this is King Henry. So this was a really cool visual just to see how the data came out all together versus, again, over the expected. Then we move to the top 15 players by average explosive over expected. We have some receivers, tight ends, and still some quarterbacks as well. As you see, Josh Allen is just out here. A lot of explosive plays. Here's how our final top 15 looked overall. As you can see, people like Kirk Cousins, quarterbacks. So I really enjoy looking at the individual one where you can see like, oh, that's who were the tight ends. And, Cook, Gresham had the total plays, the explosive plays, the average predicted, the average XOE, and you can see who did what. I mean, look how many explosive plays Travis Kelce has, but yet he was expected to have more. So I find that to be really cool. I actually find it to be really cool to look at the top 100 table, but and then you can see a different position like wide receivers. Reynolds had showed up through everything because it's like 11 out of 20. So Wilson, Higgins at 80. Obviously, all the 0.9 and up are really impressive. Benjamin showed up a lot, and you could tell these are players that are not always, because Higgins and Green are there, and Ridley. There's a T Higgins. But it's players that get the long ball, right? So that was interesting. And then I believe that covers all of my outputs. Yeah, I was in 13. Yeah. So I'll show you the code real quick. So, that's all the steps. After step 9 and 8, we start getting into all those visualizations I started to show you, and then our step 14 is where we start showing the tables, the GT tables over here, and then we have them separated as well. But thanks for watching. Apologies that it's kind of long, guys. Just wanted to get into all the visualizations and all the cool data and results that you could get from this. Of course, there's a lot more tweaking you can do, but some of these were really helpful in helping determine which player, where there's value, underrated value that might not be seen, which players outperform their and how to manage. If I notice we're 6 plays into a drive and I believe in this, how does that change my coaching? So thanks for watching, hope you enjoyed.